Hey folks, in this video we're talking about the periodic table basics of the periodic table. We'll table the complicated stuff until later. Nifty, so let's talk about our objectives. I want you to be able to explain generally how the periodic table is arranged. And this goes for atomic number, groups, and periods, or periods and groups. And also the different types of elements and different ways that we sort elements out on the periodic table. And I also want you to be able to use the periodic table to determine important information about an element, or maybe more than one. And there will be some new vocab in here. We'll say period and group a bunch of times. We'll mention noble gases and halogens and alkali metals and earth alkali metals and transition metals and rare earth metals. That's a lot of metals. And also non-metals, things that are specifically not metals. So let's get going with that. The basics of how the periodic table is arranged. It starts with atomic number. As we move right to left across the periodic table, we're going to see that atomic number increases one by one. So as I take one step over, or one square over, the atomic number goes up by one. If I move over another square again, the atomic number increases by one. Very good, very fun. So that's what I just said. And as we move down the periodic table, we're also going to see the atomic number increasing, though not by increments of one. It will vary. So the periods from which the periodic table gets its name. Well, periods are what we call the rows of the periodic table. Not sure why they came up with that name and didn't just call them the rowic table. Maybe it didn't sound as cool. And so this is going to matter a bunch to us, knowing which period an element is in as we study electron configuration. There are groups too. This is what we call the columns of the periodic table. This one actually makes more sense because elements that are in the same group or column generally have the same properties. So it makes sense to call them a group if they're going to behave in similar ways. That one I can get down with. Period's a little silly. And so this also has to do with these cool things called electron configurations, which we will study in the future. And so forlorn lines, like why don't we just call them rows and columns? I don't know, forlorn line. I mean, the group thing makes sense, and the periods for rows swapped on, not so much. Anywho, other ways we can break up the periodic table is into different parts. There are the main group elements, these dudes in red, and these dudes come up a lot. Fun. I'm not exactly sure why they call them main groups, but it's some history. There's also these cool dudes in the middle called transition metals. Let's take a look at them again in black and bold. So the transition metals are nifty, and there's other ways that we can divide up the periodic table, such as breaking it into metals and non-metals, or even looking at named groups. Let's look at that now. So if we're going to talk about named groups, there are a few that are very important and we're going to focus on. Those would be the noble gases. They're the group furthest to the right, and they're very non-reactive gases, which was why they're called noble, because like nobility doesn't get off their butt and do nothing. These gases don't get off their butts to do nothing. They are very non-reactive. And this is really helpful for making sense of studying chemistry. Next to the noble gases are our friends the halogens, and these dudes come up a lot. So it's kind of useful to know that they are together the halogens. We also have our alkali metals who make it onto the scene a bunch. They're the first group on the left, and also the earth alkali metals who are in here. So these four groups of elements are going to be seen very frequently as we are doing our studies of chemistry. We can also break up the periodic table into metals and non-metals. So let's focus on the metals first. This is going to be most of the periodic table and generally the left side, excluding hydrogen. Hydrogen is not a metal. And so the general properties of metals include that they are typically solid, except for my dude mercury, and they're typically malleable. We can bend them very nicely, and they make nice bends and shapes, which is why jewelry is made of metals. They also lose electrons very easily, and that's important for us as chemists to think about. So when they lose electrons, they form ions because there's not the same balance of protons and electrons, and we call the positively charged ions cations. So metals like to form cations, positively charged ions. And we'll talk more about ions later. And so we can even break our metals up into more sections. We already heard about alkali metals and earth alkali metals and transition metals, and there's also the rare earth metals. So let's look at those sections now. Rare earth metals, pretty rare. We're not going to talk about them a ton. So those are those different sections. And so we also can talk about our friends, the nonmetals. They generally live on the right side of the periodic table, except for hydrogen, who got stranded. Hydrogen's in this group because even though it shares properties with these dudes, it's not a metal. It's very interesting. Hydrogen. General properties of hydrogen and other metals, non-metals, is that they are usually gaseous. gases, or if they're going to be solid, they will be very brittle and break if we try and bend them. And they like to gain electrons as opposed to these metals who like to lose them. Nonmetals like to gain electrons, and when they do, they're going to form negatively charged ions, which we call anions. Like it's a negative ion. A negative ion, that's cute. And so our nonmetals include our friends, the halogens and the noble gases. And most living things, like myself and maybe you, if you are not a robot, are made of nonmetals. That's fun. A lot of hydrogen and carbon. So there's other ways we can organize the periodic table. There are these things called blocks. We can break it into S, P, D, and F blocks. These are important for studying electron configurations, so I figured I'd give them a shout out now. And so, yeah, here they are. Our alkali metals and earth alkali metals make up the S block. The other main group elements make up the P block. Our transition metals are the D block. And our F block, which we will talk about very little, is the rare earth metals. Fun! So if you want to look at the periodic table and get some information off of it that's useful, one thing you will always be able to find is the element symbol. These are the 1 or 2 letters that are used to represent an element. One thing you may or may not find, if it's a good periodic table you'll find it, is the name of an element. You will definitely always find the atomic number, or Z, and it's important to remember that that is the same thing as the number of protons in that specific element. And it's always going to be an integer or a whole number value. And that's going to help you if you ever get it mixed up with the atomic mass, represented by a capital A. And so atomic mass is not always present on a periodic table, though that's stupid if it isn't. And the atomic mass is always going to have a decimal value. It's not going to be an integer or whole number. And it's always going to be larger than the atomic number. So that's a nice way to help you prevent yourself from mixing up the atomic mass and atomic number. And so here we can see how those might be displayed on a periodic table. I just took this little chunk out of another one. And so the atomic number typically found up in the top. Atomic mass is typically going to be somewhere lower. This is pretty representative of what you would find. Nifty. Well, here's a periodic table of cuties. Oh my gosh, I love the dude with the mustache. Oh my god, I didn't notice that guy. So many mustache dudes. Anyway, mustache. Let's end this video. I hope you understand a little bit about how the periodic table is arranged, if not why. We'll learn about why it's arranged particularly the way it is. And I hope you feel good about using it as a reference tool to understand elements more so. Anyway, ta-ta. Have a great rest of your life.